All right, so another area of data measurement is going to be measures of variability. And, for reference, variability is really the key part about how statistics works. And variation between occurrences gives us an idea about the predictability of an outcome. So, for example, if something varies a large amount, it's more difficult to create some kind of prediction from that data set. However, if the variation is small, it's a lot more predictable because with a little amount of variation, you can have a better guess of what's going to happen next. So variability is really kind of the essence of statistics, and it's also some of the essence of data analytics. So here we have a data set of two funds for investment. We have Fund A and we have Fund B. And I'm going to show you this data set in Excel. There's a 24 years here, and I'm going to show you both years. But notice that Fund A every year has $1,100 dollars of payout, where Fund B varies. Some years are really small, like 350 or 300. Some are really huge. Some are like at 1,600. So there's some variation. Now, here is the rest of it. So there's 24. Again, 20 years. Again, looking at the final years of Fund A, it's still 1,100 every year, where Fund B has more variation still, even going as low as 800 and as 100, high as 1,750 or even $1,800. Now, one thing to pay attention to is that the average for both of these data sets are equal. So let's kind of take a look at these and explore it a little bit. And if I was going to create a histogram for each one, you can see that out of 20 years of payment, there has been 20 distributions or 20 occurrences of an $1,100 payout. However, over 20 years for Fund B, this one over here is Fund A, there has been variation, and now we can start to see this kind of distribution. So now we can calculate an average, we can calculate some variance, etc. So this allows us to be able to make some stronger predictions. This one, the prediction is pretty easy. Next year it's probably going to be $1,100. This one, it's not so easy, but it's a lot more fun, and to be fair, it's a lot more realistic. Let's before we get into calculating all the things, let me show you what we're going to be calculating in Excel. One important thing that we're going to be dealing with is the range of a data set. The range is nothing more than the maximum minus the minimum. So max minus the min of all the values of a data set. Okay. So looking at the home sales that we saw earlier, the largest was 456, the smallest was 108, and the difference, which is the range, was 348,000. Okay. So remember, that is influenced by extreme values. So if you have anything crazy in your data set, then it could highly influence your range. Variance is a measure of variability, okay, that looks at all of the data. Basically what happens is as we look at an average, let's say that this line represents an average value of all of the data, right? We're here. Okay, so this is X bar. And we want to be able, then we find out some measures end up on the left side of that line. Some measures are on the right side of that line. And what we're doing is actually we're measuring the distance each of these dots are going to be to that average, right? And then with this gives us an idea about the variance. And by the way, when we do the variance, there is a squaring of that variance, and that ends up becoming a positive number only. So we then calculate our sample variance in this manner. As I mentioned before, you're going to be dealing with this more in statistics. Just know that variance is a key item when it comes to measuring variability. We'll go over this example here shortly, but this is a basic example of how to calculate your deviation. Now, we also have a standard deviation, and it's the positive square root of the variance. And it so happens that we seem to be more concerned about standard deviation because of its relationship to a normal distribution. We're always going to be looking at the standard and not the population, unless, of course, we can be certain that we have a population of measures. And a population, of course, if you recall from our previous lecture, is the measurement of everything that it possibly could be. But if you're taking measures of people, typically you're only getting a sample of the population. You can't measure everybody. So here is the data set, and we're going to go over this top portion of this in a later lecture. We're going to be going over percentiles, and I'm not going to worry too much about the coefficients of variation. I think that's going to be something a little more advanced that I think that your statistics program should provide to you. All right. So let's go over to Excel, and I have everything set up. I don't know why that's there twice. That's strange. So here is all of those funds that we were talking about earlier, right? So here's fund A, here's all the 20 variances. And what I did is I put in the average here at the bottom. You can see my formula up here. And you can see that average comes out to 1100. That's a no-brainer. And then this data set here, same type of thing. We look here at the bottom, and I forgot to click on it. There we go. And then you can see that's also the average, right? So here's how we calculate all of these data points, or these measurements. So we already have the average, but I'm going to do this again. So it's the average of this column, median, same column. Now, if you remember mode, I have to select both mode 1, mode 2, and hit equal, multi-mode. Actually, excuse me, mode, multi, thank you. And then, of course, select all this, Control, Shift, Enter. Isn't this interesting? Now that we know that there's only one data, mode 1 and mode 2 are identical. Very important observation. Variance is nothing more than var.s. That means we're dealing with the sample. So do the variation of that column. Notice that's 0 because there is no variance. The other one is standard deviation of the sample. And again, that particular column. This equals the minimum of that column. This equals the max of that column. And then the range we always have to do is a formula which equals the max minus the min, and it should be 0. All right. Using my rule of relative referencing, I should be able to take these formulas, copy it from left to right, and now I can get the same data or the same data measures of data here on the right for Fund B. So here you can see a lot of differences. Let's kind of point out a few things. So the mean is the same, the median is the same. However, we have some different modes. In the second data set, we have differences in variance, and that makes sense because you can see that visually by the differences in values from year to year. Here we have a min and max, and then we have a range of 2400. Here there is none. All right. So this is already helping us understand this data set a little better.